Welcome back to our YouTube channel. Welcome back to SQC Tutorials. In today's video, we're going to talk about vectors. But meanwhile, for my Delsu students, I wish you a very happy resumption. I wish you success in this second semester for my Delsu 100 level students. So in this video, we're going to talk about vectors. But before I continue, if you are watching my video for the first time, please do not forget to like and subscribe to our YouTube channel, share our videos, and we need your comments in the comment section. Thanks. Now, what are vectors? The word vectors are not actually new to most of us. This is not the first time we have heard of vectors. So vectors are actually physical quantities that have magnitude and direction. We played with it during our secondary school, SS1, SS2, and so on. Vectors are physical quantities that have direction, e.g. we have your velocity. Your velocity is actually speed with direction. We have your displacement. They are physical quantities that have magnitude and direction. When we say magnitude, we actually mean the size of that quantity, the size of that quantity. Let's assume we are talking about a scalar quantity of mass. Let's say we have a boy, let's say we have a bag weighing 20 kg. Now, this is the size of, or the weight of the mass of that bag. This mass is what we call the magnitude of the quantity. So when we talk about the magnitude, it is actually the size of that vector. Now let's say you have a car and you started your journey from this point. You move from here to this point and from here to this point, and you went back to this point. Now when you are talking about distance, you are considering how much you moved without considering the direction. But when you are talking about displacement, you are talking about from where you started and where you stop. What direction are you? So the distance you moved is actually this place, this place, this place. But your direction is actually, your displacement is actually just this part. So this is what vector is all about. So vectors are represented with arrows. Vectors are represented with arrows. This is how you represent vector. And they are denoted with AB, putting an arrow at the top. You can leave it like this, or you can put an arrow here. So when you see this, they're talking about a vector. When you see this, they're talking about a vector. And this is the direction. Sometimes you can see an angle to the horizontal, theta. But you hardly see that. It is not really necessary. So vectors are represented like this, or in this form, or you can also see them as small letter. And while the size of the vector is actually the length of this line. Now the direction of the vector is represented by this arrow. This is telling you that this vector is moving towards this direction. If it was like this, it's telling you that the vector is moving towards this direction. So the size of that vector is actually the length of the vector. And to know the size, or we denote the size of a vector, that means the magnitude, as this. So whenever you see this, we are talking about the magnitude of the vector. Or you see this. So if you see this, we are talking about the vector itself. When you see this, we are talking about the magnitude of the vector. Let's consider our x and y plane. Let's say these are x, our y axis, our x axis, and our y axis. And we have a vector A. We have a vector A, 2i plus 3j. 2i plus 3j. Now what this I means is your x-axis, and this j is your y-axis. There's also another axis which is your z-axis, so they are represented as k. So what this means is you move towards the positive x-axis twice, 1, 2, and move towards the positive y-axis 3 times. So you have 1, 2, 3. So this is the point. This is the point. This is actually the vector we are considering now. This is actually the vector we are considering. Now the magnitude of the vector is actually the length of this place. Now you can use your Pythagoras theorem to get that. But in this video, we are not going to do any calculation. I'm just giving an instance. So let's move over to the types of vector. Types of vector. We have various types of vector. Various types of vectors. Some are under some. They can be compared to each other. So the first type of vector here is what we call the zero vector. zero vector. As you can see, 0, the magnitude of that vector. Meanwhile, all vectors have direction. Now we are talking about the magnitude here. The magnitude or the size of that vector is 0. Now you may not understand the importance of this until my next video, when we'll be solving some diagrammatic questions. You'll be seeing where these 0 vectors come into place. So the magnitude of the vector is 0. So any vector that the magnitude is 0 is called a 0 vector. The size of that vector is 0. So the second type of vector we have is the unit vector. The unit vectors are vectors that their magnitude is 1. The size of that vector is 1. Irrespective of the direction, when you find the size of that vector or the length of that vector, it will give you 1. So the magnitude is 1. Magnitude is 1. The third type of vectors we are going to talk about is or are equal vectors. Equal vectors. What are equal vectors? As the name implies, any vector that have the same, if you're comparing two vectors and they have the same magnitude and the same direction, they are called equal vectors. Let's say you have this AB and you have CD, and you are told that AB, the magnitude of AB is 4. That after looking for this size of the vector, you add 4, and after looking for this side of the vector, you add 4 again. Because they have the same size and they have the same direction, it means that they are equal vectors. So what it implies is that all equal vectors are parallel. Take note of that. All equal vectors are parallel, because if they are parallel, it means they have the same direction. Now when we are talking about the direction, we are doing it with respect to the x-axis. Now these two vectors have the same direction. If I trace the x-axis and I find the angle here to be 30 degrees, for example, and I trace the x-axis here and I find the angle here to be 30 degrees. Now because they have the same angle to the horizontal, we are seeing that they are going towards the same direction. So anytime you see two vectors that have the same size and also have the same direction, they are called equal vectors. Now what if they have the same size but they are having opposite direction? I'm not saying they have just different direction, they have opposite direction. Now instead of this arrow to be going towards this direction, this arrow will be going towards this side. Those type of vectors are called negative vectors. Negative vectors. So if A and B were equal, if they had the same size, but opposite direction, we can say that the magnitude that AB, this vector, is minus CD. This is what negative vector is all about. They have the same size, but they have opposite directions, so they are called negative vectors. But when they have the same size and also have the same direction, they are called equal vectors. When the size is 1, they are called unit vector. When the size is 0, they are called 0 vectors. So let's move to the next type of vector. Now let's talk about collinear vector. Collinear vector. Now we have collinear vectors. Collinear vectors are vectors that are parallel to each other, or they are parallel to a certain line. Now let's say you have a vector like this, you have another one like this, you have another one like this, you have another one like this. Now they do not have the same direction. They have the same, this 4 has the same direction, but this one has an opposite direction. Now because they are parallel, that means they have the same angle to the horizontal. They are called collinear vectors. Now irrespective of their magnitude, we are not concerned if this is bigger than this or if this is equal. What we are concerned is their direction. Because they have the same direction or are parallel to each other, irrespective of this direction. You can be going towards the opposite side, but because they are parallel, they are called collinear vectors. Now, it doesn't matter if you are going towards the same direction or in opposite direction. You can see this is going towards the opposite side, but it is still a collinear vector to this because they are moving, they are parallel to each other. Now, collinear vectors are divided into two. They are divided into two. We have the like vectors and we have the unlike vectors. Now, as the word implies, like vectors are vectors that look alike. Now, they look alike in the sense they are moving towards the same direction, meaning that they are parallel to, they are moving towards the same direction, but they may not necessarily have the same magnitude. They don't have the same they may have the same magnitude, they may not have the same magnitude, but they are moving towards the same direction. Such a vector is collinear, but we call them like vectors. Now, if they are now moving in opposite direction, let's consider this vector and this vector. They are parallel to each other, which means that they are collinear. But they are moving in opposite directions, so they are called unlike vectors. So it means that if two vectors are equal in all equal vectors are like vectors. It means that all equal vectors are like vectors. It means that all equal vectors are actually collinear because they are equal and they have the same direction, meaning that all equal vectors are parallel. So if all equal vectors are parallel, it means that they are also collinear. But not all equal vectors are unlike. Equal vectors must have the same direction, but unlike vectors have different direction. Now, for like vectors, they may have the same size or not, but one thing is common is that they have the same direction. The only thing restricting these two is that equal vectors must have both the same direction and the same size. Now, negative vectors are actually unlike vectors in the sense that they are moving towards the opposite direction. But the difference between a negative vector and an unlike vector is that for negative vectors, they must have the same size, although they are moving in opposite directions. But unlike vectors are vectors that they don't necessarily need to have the same size, but they are moving in opposite direction. So I hope this explains like and unlike vectors. So let's move to the sixth one. We have coplanar vectors. Coplanar vectors. Now, what are coplanar vectors? They are vectors that lie on the same plane. Now, in actual sense, when comparing vectors to know if they are coplanar, we compare 3 or more vectors. We do not compare 2 vectors because no matter how you position 2 vectors, they must lie on a certain plane. They must lie on a certain plane. So we compare this, we compare them with 3 vectors or more. Now let's say you have a plane. A plane can be a flat surface. Let's say you have a plane. And this vector is lying on this plane. This vector is lying on this plane. This vector is lying on this plane. But this vector is coming below the plane. Now, because these 3 vectors are lying on this same plane, they are called coplanar vectors. But this one is not lying on this plane, so it is not a coplanar vector because it is not lying on the same plane. Now, if 2 vectors are not parallel to each other, definitely they are non-collinear vectors. So when you find out that the 2 vectors are not parallel to each other, they are simply non-collinear vectors. So let's come back to our coplanar vectors. Now, because these 3 vectors are lying on the same plane, they are called coplanar vectors. Let's say you have a paper here, and no matter how I rest this paper, I can position these 2 things to lie on top this paper, to lie flat on this paper. I can position this one like this. I can decide to position this one like this. Now, because these 2 broomsticks can lie on the same plane here, they are called coplanar vectors. Anything that makes this one cross or move in a stupid direction that does not lie on this plane it is no longer a coplanar vectors. So in actual sense, if we are comparing only two vectors, I'm using this as an example, no matter how I position it, there's a way I can put a flat surface that these two will actually lay on the same surface. But that's not our concern. In our next video, we'll be talking of how you actually know if three vectors are coplanar. But just know that when three vectors or more are lying on the same plane, they are called coplanar vectors. Now let's move over to the next type of vector. Alright, the next type of vector is co-initial vector. Co-initial vector. These are vectors that are starting from the same point. Let's say you have a vector moving towards this direction, and you have another vector moving towards this direction, and you have a third vector moving towards the direction. Now, because they are starting from the same point, they are called co-initial vectors. They are called co-initial vectors. It is possible that this could come in an opposite direction. And it is possible that when this is coming towards an opposite direction, it can also have the same magnitude as this. So it means that there are some co-initial vectors that are actually negative vectors. There are some co-initial vectors that are actually unlike vectors. That is to say, there are some initial, and anything that makes them to be unlike vectors, it means that they are collinear. So you can see how these vectors are related to each other. So anytime the magnitude of a vector is 0, it is a 0 vector. Anytime the magnitude, the size is 1, it is a unit vector. Anytime two vectors have the same magnitude and the same direction, they are equal. Anytime they have the same magnitude, but the only difference is they are opposite in direction, not just different direction, they are opposite in direction, it is a negative vector. Then anytime they are parallel to each other, irrespective of their direction, if they are parallel to each other, they are called collinear. Now, if they are parallel to each other and have the same direction, they are like vectors. If they are parallel to each other and have opposite direction, they are unlike vectors, which implies that all negative vectors are actually unlike vectors, and all negative vectors are collinear. All equal vectors are like vectors. All equal vectors are collinear. Now, if three or more vectors are lying on the same plane, they are called coplanar vectors. And if they are starting from the same origin or the same point, they are called co-initial vectors. Now let's move to another one, displacement vector. This vector is gotten from the position of your starting point and your ending point. I made mention of displacement when I was talking about vector. Now, when you are considering the vector between your starting point and your ending point, it is known as a displacement vector. Now, it is possible that this vector moved like this, and moved like this, and moved like this. But the displacement vector is actually the starting point to the ending point. So this is actually the displacement vector. And lastly, we'll talk about position vector. Position vector. Now, position vectors are actually with respect to a certain reference point. This reference point is usually called the origin. So position vectors are with respect to the origin. Let's say you have the origin here and you have a plane here. Now, if you are considering a point, the position vector of this point is actually from 0 to that point. So let's say the point is P. So OA is actually the position vector of the point P. If I have an arbitrary point Q, the position vector of Q is actually the vector formed from this point to this point. So the position vector of Q is given as OQ. So you move towards this direction so times, and move towards this direction so times. So these are all the basic types of vector we have. So just so you recall, when vectors have their magnitude to be 0, they are called 0 vectors. When the magnitude of a vector is 1, they are called unit vector. When they have the same size and the same direction, they are equal vectors. When they have opposite direction, not just different direction, they must be opposite. If one is going towards this side, the other must be going towards the other side. But one thing is that they must have the same magnitude. They are called negative vectors. Now, when they are parallel to each other, whether you are going towards this side or you are going towards this side, so long they are parallel to each other, even if it's at the bottom, so long they are parallel to each other, they are called collinear vectors. Now, if after they are being collinear, they are moving towards this direction parallel, they are known as like vectors. If they are moving towards opposite direction, irrespective of their magnitude, they are called unlike vectors, which implies that negative vectors are unlike, equal vectors are like vectors. Both equal and negative vectors are actually collinear because they have the same direction. Now, if three or more vectors are lying on the same surface or plane, they are called coplanar vectors. If they are starting from the same point, they are called original co-initial vectors. And if we are considering the starting point to the ending point of a certain vector, it is known as displacement vector. And if you are considering the position of a certain point with respect to the to a reference point called the origin, they are called position vector. So that will be all for this video. In our next video, we'll be solving unit vectors, how you know unit vectors, how to get the magnitude of a vector, how to get the direction of a vector, and how to know if a vector is coplanar, how to know negative vectors, and how to solve vectors. So thanks for watching. Please do not forget to subscribe to our YouTube channel, like our videos, watch more of our content, follow us on Facebook, follow us on Twitter, and all social media handles. Your success is our concern. Thanks for watching.
Marathon class for nursing aspirant and post-UTME students in all universities in Nigeria. Join thousands of students now at exclusive tutorials for nursing and post-UTME blast. Link below.